Hi everyone. Today we will discuss some of the common interview questions asked in the data science interview questions and answers. Actually, data science, as we all know, is quite a broad field. So the interview questions in data science can involve statistics, machine learning, uh, programming, and other domain specific, questions. So let's start with our first question. The basic question: what is data science? So data science is actually a multidisciplinary field. It involves a lot of disciplines like techniques, algorithms, processes, and systems to extract valuable insights and knowledge from the data. So you use all these some techniques, algorithms, and processes, and some systems to get some insights into the data. And the skills that are involved are statistics, machine learning, computer science, and domain expertise to interpret this and analyze this data. The data can be structured or unstructured. It can be any kind of data. It can be labeled or not labeled data, and yeah, it can involve like supervised or unsupervised learning, because of the labeled and unlabeled data. Uh, so the next question is, what is the difference between supervised and unsupervised learning? Supervised learning actually in data science involves training a model on labeled data set. Okay, where the algorithm is trying to learn to make predictions based on the pairs of input outputs, and the data is labeled. While on the other hand, the unsupervised learning deals with unlabeled data, where the algorithm tries to find patterns or clusters or relationships between the data. It tries to there's some data which is unstructured, which somehow makes no sense, and we are applying some algorithms to find the patterns and clusters and to somehow find the relationships between the data. While the supervised is already labeled, they are pairs, and you have some relationship between the data, and you're trying to you know the algorithm is trying to make predictions based on that, and trying to create a training model based on that. Okay, what is the difference? What is the data science workflow? Yeah, data science workflow. Data science workflow involves the following stages. Number one is the data collection. Data collection is, for example, how you gather data from different sources. It can be sensors, it can be databases, or web scraping, or it can be any kind of raw data, that any source, any systems which are providing us the data, because data collection is the first step in data science workflow stages. The next process is data cleaning and pre-processing. Data cleaning and pre-processing is like, you arrange the data in a certain way. You remove, for example, the duplicates, you fit in the missing values, and you you know kind of structure, kind of what should I say, like kind of rearrange or restructure the data in a certain way, like clean it, like remove the like inconsistencies, and make it suitable for data analysis, like scale the data, remove all the missing values, or find the missing values, and remove this duplication of the stuff. And the next stage is explanatory data analysis, which is also the short form EDA used in the industry, where you explore the data or analyze the data. EDA process. It's like you create patterns, you find out what are the outliers, what are not fitting into these patterns completely, what kind of what things in the data, and this is like data analysis thing. And now next stage is feature engineering. So feature engineering is like creating new features, like transforming the data so that it is more structured, or it makes more sense, and it helps to improve the machine learning process model, and it is more informative. That's what you do with the data in feature engineering stage. Then next comes the model building and training model. Model building and training model involves like you select a certain kind of algorithm and then you train it on this data model, on this data set that you have got after all these stages. So like the selection of this algorithm and training of this algorithm on the data set is called model building and training model. The next stage is called evaluation and selection. Evaluation and selection is the process in which you see what was the performance of this training model or the algorithm or the model that was created using this algorithm in the previous step. What was the accuracy, what was the precision of this model. Different time there are different matrices in data science that are used to do this evaluation of our training model. The next last step is deployment and monitoring. In deployment and monitoring stage, the model is made available in the production environment and it's available for use. And then over the time, the training model's performance is assessed. If the model is giving the right results, if it is performing the way it should have been performed, like over a period of time. So you put this model on production and then you keep monitoring over time. That is called um, this deployment and monitoring stage. Yeah, so these are the data science workflow stages. So data collection, data cleaning and pre-processing, exploring data analysis, feature engineering, model building and training model, evaluation and selection, deployment and monitoring. So I hope you understand the main concept of the data science workflow stages. So what is a feature engineering? So feature engineering, as we have seen in the previous slide, it is one of the data science workflow stages. The interviewer can ask you what is exactly the feature engineering stage. So feature engineering stage, as we have discussed before, is the process of creating new features and transforming the existing ones to improve the performance of the machine learning model. You know, you you transform the existing features of the data set to improve the performance of the machine learning model. Maybe there are some improvement areas in our data set that can help in improving the machine learning model. It involves selecting, modifying, and combining features to make the data sets more informative and relevant for the tasks at hand. So this is feature engineering stage in the data science. Cross validation. So cross validation is a technique that is used in data science to assess what was the performance of our machine learning model. For example, you split the data set into multiple subsets, or you can call them folds also, and then you train on your model on some of the folds, and then you evaluate it on the remaining folds, and then you estimate how well the model will generalized will perform on a generalized unseen data. And it will help us detecting the discrepancies in our model. So this is called cross validation. What is overfitting in data science? Overfitting occurs actually when our training model it's learning on the training data, and it learns really well. It's performing very well on our trained data, but when we give an unseen data to our training model, it performs very poorly. So this is called overfitting, in overfitting in data science. So how can you prevent this to happen is, for example, you use more training data and reduce the complexity, simplify the model, use regularization techniques like L1 and L2 regularization. These techniques can also help uh, to prevent overfitting, or cross-validate the model to assess its performance on an unseen data. In cross validation, we have our data sets, we create different folds, different subsets of the data sets, and we apply the model on some of the folds and then see how they perform on the other folds or other data sets. So this is how you can somehow do some things to prevent overfitting. Like, so the term is basically used if the model is performing really well on the training data that was used to train the model, and it is performing very, very bad on the unseen data. That is called overfitting. So what is the regularization in data science? Regularization is actually a technique which is used to prevent the overfitting by adding some penalty term to the model's loss function. This regularization technique encourages the model to have smaller parameter values, reducing the complexity and improving the generalization to unseen data. And common forms of regularization include L1, lasso, and L2, ridge regularization. I think you should be familiar with the model loss function. If not, in the next question, I will explain what is a model's loss function. A model loss function is actually a mathematical term, function that somehow tell us in a certain quantity the error or discrepancy between the predicted values generated by the model and the actual targeted values in a supervised learning problem. So you have an actual targeted value and what were the values predicted. So this error or this discrepancy between the predicted values and the actual targeted values is, we use a mathematical term for this, and that is called a model loss function. It is also called a cost function or objective function. So, and the primary purpose is for the loss function is to measure how well or how poorly the model the training model has performed or is performing. So explaining it again in simple terms, like let's say you have a supervised learning environment. To calculate the loss function, what you do, a supervised learning environment, you have a certain data set, and then you have actual targeted values that should be the values based on this data set, and then you train a model which is going to predict the values that are going to be generated based on the data set that was provided, and then the values predicted by the data set and the actual targeted values in this supervised environment are compared, and then some single scalar element that is quantifying this difference between the actual and the predicted values is calculated, and that is called the loss function or cost function or objective function of the training model. So the next question in data science interview: what is bias in machine learning? Bias actually in machine learning, it refers to those errors, systematic errors, or those inaccuracies in our predictions that are caused by a simplistic model that doesn't capture the underlying patterns in the data. So those errors and inaccuracies in the model that don't capture the underlying pattern in the data is called bias in machine learning. This term bias is used for those errors and inaccuracies. And how to address this bias in machine learning? For example, you can use a more complex model, collect a more diverse and representative data of the problem, adjust the model's hyperparameters, and consider techniques like oversampling or reweighting for the imbalanced data set. Because if you do oversampling or reweighting, then we can have a better version of our data set, and that can also help to address the bias. Okay, now what are the different types of loss functions? As we already discussed, that loss or cost function or objective function is actually the discrepancy between our predicted results and the real results. So what's the discrepancy between them is called the loss function, and the different types of loss functions are mean squared error, binary cross, empty loss, hinge loss, categorical cross entropy loss. So mean square error is actually used in the regression problems, and it is the average squared difference between the predicted values and the actual values. Binary cross entropy loss is actually mostly used in the binary classifications, and it is the difference or the dissimilarity between the predicted probabilities and the actual values, actual binary values. So the difference between the predicted probabilities and the actual binary values, the dissimilarity or difference, is called the binary cross entropy loss. It is mostly used in binary machine learning algorithms, and it is, for example, neural networks also use this. And now hinge loss or hinge loss is actually a loss or cost function that encourages the true classifications or correct classifications, I should say, by uh, penalizing the predictions that are too far from the boundary, the decision boundary, I mean. So that's called hinge loss. Now the categorical cross entropy loss. It is used in multi-class probability. So it measures the dissimilarity between the probability class and the true class. So it's used in multi-class uh, classifications, multi-class classifications. So difference between the probability classes and the true classes. Now the next question, difference between precision and recall. Actually, precision and recall are two metrics that are commonly used in the binary classifications. And precision actually measures the fraction of the true positive prediction out of all the positive predictions. So, out of all the positive predictions, what are the true positive predictions? What are the fraction of the true positive predictions? Is called precision. It focuses on accuracy of positive predictions and is calculated as TP plus FP, TP/TP plus FP. And recall is also known as sensitivity, and it measures the fraction of true positive out of all actual positives. And that's the difference. One is the fraction of true positive out of all actual positives, that is the recall, and the precision is the fraction of true positive predictions out of all positive predictions. So this is a comparison of positive predictions with all of the other positive predictions, and recall is the comparison of the true positive fraction of the true positive predictions out of the actual positive predictions. So predictions and the actual positive is recall, that comparison, and the measure of the predictions and all positive predictions is the precision. Okay, the concept of ensemble learning. So as the name ensemble shows, the ensemble learning is actually a technique that combines the prediction of multiple machine learning models, base learners. You call those multiple machine learning models as base learners. So based on those base learners, like multiple machine learning models, using this technique, you produce a final prediction that is more accurate and robust than the individual models. So you have many models, and those models make a prediction, and using those models, you make a final prediction to make more robust and accurate results. And what are the common ensemble models? They are bagging, random forest, for example, boosting, and the example of boosting is AdaBoost and stacking. Okay, the next question. So binary classification. So binary classification is a very, very fundamental concept in machine learning. And binary classification is used both in data science and machine learning, and it is a type of supervised learning where the goal is to categorize the data in one of the two possible classes or categories. So the outcome is either 0 or 1, or yes or no, you can say in the descriptive terms. So and that's how you classify the data. And binary classification applications are mostly spam detection, fraud detection, sentiment analysis. So happy or sad, things like the medical diagnosis. So if you have some disease or not, yes or no. And the algorithms that are used in binary classification are logistic regression, support vector machines, decision trees, random forest, k nearest neighbors, and neural networks. So these are the uh, algorithms that are used in binary classification.